Barbara Fox, and this is the Element Election. Today's show is all about carbon, and here with us today we have two carbon-crazy twin scientists, Damien Carbon and Alyssa Carbon, who believe that carbon should win the Element of the Year award.
Hi Barbara, thanks for inviting us here today to represent carbon.
No problem. You two were definitely the most animated about carbon out of all the scientists I could have chosen from. Now, to start off the show, how about you tell me a bit of the basics of carbon?
Well, a few of the properties are like a lot of other elements. It's a non-metal and it's a gas at room temperature.
It also makes a ton of important compounds like CO2, which is carbon dioxide, and
H2CO3, and that's carbon acid. Oh, and I can't forget CO, which is carbon monoxide.
Yeah, and there are a lot of additional properties too.
A few of those are that it melts at a high temperature of 3,500 degrees Celsius, that it's a good conductor of heat and can be burned for fuel.
Another two that it can form are one of the hardest substances like a diamond and one of the softest substances like graphite.
That all sounds great, but I have a question. Why should carbon really win Element of the Year award?
Well, isn't that a little obvious? Carbon has taken a place in our world since before we were here. It was always around us, and without it we wouldn't be here because carbon is in everything. It's in our atmosphere and the Earth's crust. It's also in the bodies of plants and animals. When we breathe, we exhale carbon dioxide, and when plants draw in air, they take in carbon dioxide. So without it, our world just wouldn't be here.
Oh, I see. Well, that has certainly changed my point of view. How about you tell me about carbon in the periodic table?
Sure, let's head over to the prop area to show you what carbon has to do with the periodic table.
Let's go!
Here's an example of the periodic table. It's organized by the atomic number, period number, valence electrons, family name, density, classification, and state at room temperature. The atomic number is the number above the big letter or letters on the element's space. In this case, carbon's atomic number is 6, because it's 6 on the periodic table. The period number is here. It shows how many electron shells an element has. So that means carbon has 2 electron shells, which is shown here. And those numbers are how many electrons are in the electron shells. Next, it's organized by valence electrons. Valence electrons are the electrons in the outer shell. These certain electrons are the numbers along the bottom. And with that, carbon has 4 valence electrons in its outer shell. The periodic table is also organized by its family, and that means carbon is in the carbon family right along here. Next is by density. The density is on the bottom of the element space, and the numbers go up as you proceed along the table. Those are the ways it's organized, but the color of the atomic symbol and element space matter too. Carbon's atomic symbol is black because it's a solid, and it's outlined in purple because it's a non-metal. And those are the basics of carbon on the periodic table.
So we're back here with Damien's amazing carbon costume. Alyssa, would you care to explain?
Yeah, sure. Damien, turn around and scoot back so everyone can see. Scoot over a little bit. Okay, so first we have the big C, which stands for carbon. Then below it we have the actual word carbon. Then below that we have 12.01, which is the mass/density of carbon. Above the big C is the atomic number, which is 6, because it's 6 on the periodic table. Then we have 2 and 4, which are the number of electrons in the electron shells. In the first shell, there's 2 electrons. In the second shell, there's 4 valence electrons. And that's Damien's carbon costume.
Wow! Good job, Damien! So Alyssa here is going to explain to me about the carbon family.
Okay, so here we have the carbon family. It starts with carbon, silicon, germanium, tin, then lead. The reason they're a family is because they all have similar properties. They all have 4 valence electrons because they're in the same valence electron row. They also contain metals, metalloids, and a non-metal, which is carbon. Carbon is a solid at room temperature. It's a non-metal. Silicon's a solid at room temperature too, and it's a semi-metal. Germanium's also a solid at room temperature, and it's a semi-metal. Tin is a solid at room temperature, and it's a metal. And lead is solid at room temperature, and it's a metal. And that's the carbon family. But I also have to explain this right here. This is an example of a carbon atom. So, the valence electrons in the outer shell, there's 4. 1, 2, and then below that, 3, then 4, because it has 4 valence electrons. Then in the first shell, there is 1, 2. And then they have the protons and the neutrons in the nucleus. This isotope is carbon-12, and carbon has 6 protons and 6 neutrons. And this is the carbon atom, and this is the carbon family.
Thanks.
Yeah.
So here I am with Damien and Alyssa, and this is Damien's whiteboard. So Damien, could you tell me some cool facts about carbon?
Yeah, of course. First of all, carbon provides all the framework for all the tissues in plants and animals. Those tissues are made of elements grouped around rings of carbon atoms.
Well, that's pretty cool.
Carbon also forms a ton of things we use daily, such as diamond, carbon black, charcoal, and graphite.
Wow, all of those things?
Yep, and it can also form more than 10 million compounds.
10 million?
And a really cool fact is there is such thing called carbon star. It's a star that's similar to a dwarf star. Its atmosphere is made of mostly carbon and not oxygen, but in normal stars it's the other way around.
Now that is for sure a lot more interesting than what the scientists last week said about the largest zinc mine being in Alaska.
Ha! Of course it is. That's why carbon should win Element of the Year award.
Okay, I know, I agree with you, but we have to finish the whole show, so how about you explain bonding to me?
Yeah, but let's head over to the prop area so I can show you with a visual.
Okay, let's go. So here I am with Alyssa, and she's going to be explaining the different things that carbon can bond with.
Okay, so there's 3 types of bonding: ionic bonding, covalent bonding, and metallic bonding. We're going to do a covalent bond because it's really hard for carbon to do an ionic bond when it has 4 valence electrons. And it can't do a metallic bond because for a metallic bond it has to be 2 metals. So, I am going to bond carbon with 2 oxygen atoms.
And that forms carbon dioxide, also known as CO2.
Yeah, CO2. So to start out, carbon has 4 valence electrons. So I'm going to draw 4 valence electrons, 4 dots around it. And oxygen has 6. So I'm going to draw 6. 1, 2, 3, 4, 5, and 6. And it has to go on the other one too, because there's 2. And in a covalent bond, oxygen and carbon share electrons, because that's what a covalent bond does. So now that we have all this, let's kind of organize it and make sure it looks better. So we're going to have oxygen have its 6 valence electrons all around like this. And then we're going to have the other one kind of similar, like that. Then for carbon, we're going to have its 4 all on the same side, or on 2 different sides. And then, once you circle them, that is CO2, because each oxygen has 8 valence electrons now, which is a full shell, and it's unstable without 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then carbon does too. 1, 2, 3, 4, 5, 6, 7, 8. And also does the other oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Now they all have stable and full valence electron shells.
Yeah.
And that was bonding.
Thank you, Alyssa.
Yeah.